Welcome back, friends. SQL section. I know there are a lot of SQL lovers are there, so we'll talk about that. SQL is very powerful and it's been there for decades in the industry, and it's for structured data, of course. So we'll talk about what are the widely used SQL syntax by agents in their workflow. So starting with the window functions, you will see this kind of code very often in in s- in agentic workflow. So what is this? What is this window function? So here you will see a select command with this some columns are there, and then you see something called row number over partition by and so on. Okay, so what it actually do, it is nothing but you are creating a table. uh, in order there is a order there is a already existing table. From order table, you are bringing the column user ID, order date, and amount. But at the same time, you are in fly, you are creating a few more columns. That is called one column sequence. You call it another running total and delta. So on the fly, you can create certain columns based on uh, something. So these you see row number. It is kind of a inbuilt function available in most of the SQL thing, where uh, you can just put a numbering for each rows. So that's the benefit of using row number, but it has to have it has to follow certain syntax. Okay, row number at what where it will generally followed by over. Again, this is a default syntax available in SQL. You will use partition by user ID. So it is telling you if there are multiple user ID, you have to partition at that level. Generally, these user IDs are generally unique in the data set, and this is a good practice. You have there will be some cases user ID can be repeated. I'll come to that, but uh, we are trying to do user ID uh, partition it by, and then it has to be sorted. Order by means is like sorting in certain way, which we provide by order date. Here in this case, order date. Now I know it's little. Sometimes it is confusing what is actually happening. We'll go to the animation. That way you will understand better. Just giving few things for. So this is for row number, and similarly, if you want to know the amount, the in a running way, in a running total, what do you mean by running I will also show. And there is also something called, you can use lag, which is basically one row at a difference level, and create delta. All these are actually window I will say row level functions. Okay, that is not generally available if you use other function like group by. That's the advantage. Let me show the animation, that way I think it's more pretty much clear. So this is very simple uh, animation, which I will try to cover it here. Okay, so this is the order table. Okay, our order table look like what it has. It has a user ID. Let's call it some Anna ban or something like that. You'll see Anna is repeated. That is possible because one person can have a multiple order in different dates, with different amount. So this is nothing illogical, nothing incorrect about this data. But when you normalize the table, that's another SQL concept. If you have a customer data, let's say user ID data, it will has to be unique there. Okay, but not in this case. This is the order table, which is generally called as a fact table. So here you'll see uh, these are there, and you you want to do something with this. So what actually you are doing by bringing this command, what you are actually seeing. So I will show you happening, what is exactly happening, then you will, it's better to see what exactly happening. So we'll start with the animation. So first it is going to that partition uh, part of it. So this is where it is selecting. Okay, then I'll just click on the next to see that what actually happened. So it has brought that data set, but you will notice that there are something happening here. uh, it has been partitioned and it has been sorted. So you can see the dates oh, for Anna is together, and then you will see the dates are sorted. This is January 5th, January 9th and 12th in this order, and this is how it has been sorted. That's what the order by order date and the partition. You see this partition, the user ID has been created as an one partition. So this particular became one partition. This is became a second partition. First you create the partition and then you sort it. Okay, so that's the action happening. Hope it is clear. Now I'll click next here. The this this row number, after that this row number has just listed down numbering from that. So it will do the numbering per partition. Okay, remember that per partition it will do the. So for Anna it will number 1 2 3, that's it, and then it will stop here. For Ben it will start 1 2, stop here. So that is the use of this row number and sequencing. What is the use? There are multiple use. I don't want to go into that, but when you see that, you'll get the idea of what is actually this code is doing. Now I'll go to the next part, which is running total. Okay, so running total, what is actually doing? I will explain. Let it complete this part. So you see, you start with Anna. Okay, Anna as a one thing. You take this amount 100. You add 100 to 50, which is become 150. That is been kept in the running total. You start with 100, you keep as it is. First row keep there, then 150, and then 350. So why I was trying to see what is the benefit of getting this information. So for example, if somebody asked as on this date, like say as on 9th January, or let's say as on 10th January, how much amount Anna has ordered. So you can quickly take this amount 150 and provide that result. So all that calculation is done in this running total. And so if somebody asks what is the total amount as on 13th of January, so this 350 total will help to get it. So that's the advantage of seeing the running total. It also help you to, let's say if you want to create a trend chart of the amount is increasing in what level of amount spent of increase, that also you can see. That's the benefit. Okay, and now for Ben also same way, 70 and 100 is 70 plus 30 is 100 has been calculated. So again, this is very common. You will see row number, sum of amount, partition by as running. Okay, so you can now actually easily interpret what it's doing it by seeing this thing. Okay, let's go to the next one. There is something called, they will often you will see called common table expression, recursive common table expression. Again, nothing to worry about it. Let me talk about this part first, which is which is like chaining the multiple SQL command to, you know, create certain result. So let me talk about this so that you understand what is exactly happening here. So here, whenever you come across with clean, okay, here you are actually creating a temporary table, and then using that temporary table you do calculation. So what is here? Here it is doing selecting everything, select all from table called raw, where amount is not null. So if there is certain amount, you just select those rows and put it as a uh, call it as a clean table. That's the first thing you did here. Then once that table, this clean, so from raw, see from raw you created a clean table. Now you want to do something on top of that. So that clean became your next table, and then you are doing certain thing. So here you are using select everything means bring all the column from the clean, and then you are adding another column here, which is rank over order by amount and disk. So remember the what we discussed here in the window function. So similarly, we have a rank also, and as soon as you see over, you will understand, oh, okay, what ranks function is generally followed by this, and then how do you want to rank? You want to rank it by the amount. So, so here you will notice you are not using the partition, okay, which is there, because this time you don't want to break them by user. For example, is then maybe the user is not there, just the amount is there. You don't want to do that, so you can skip that. Okay. Now once the rank table is generated, so in sequentially, okay, this is generated, you uh, apply a third select command on that rank table, and let's say you only want the top 10, so you will use this clause from the, because here you r is a column generated, and you use that. Okay, again, this is like a chaining of multiple action you're doing in one go. So many of the, you will see data engineers, uh, they use this kind of CTEs to do multiple things together. Let's create a temporary table in between, and whatever the outcome is comes, let's pass it to the next one. So we'll see in action, so that will you understand. Then in there is also something called, you will see with recursive. Okay, let me see if I can show you the first example first. So this is what we discussed, right? So let me show you what is actually happening, how the outcome will look like. So let's say you have a initial raw table which has these amount 100, and so we don't want null. Okay, so we don't want null, this null has to be go out. So we'll see in the action. So first thing, when you put this select command, the clean part will remove, select only 100, 250 and 80, so it became 3 rows. Okay, now when you do the next one, what you're doing, you're putting the rank by the amount value. So you are going to put the highest value as the first rank, the second one, and third one. Okay, then next thing what you're doing is going to filter here. You want only top two, you only want top two. The third one, which is this one, you are not interested, so you will cancel it out. That's the command here. Okay, and that's give you the final result of this table, which will be, it will have everything, because here you have put the star, so that will, you will have IDs also, what was originally the ID was there, and you will know, okay, the top ID was $250, and the next one was second. So the whole processing is done in a single command, and this is the result look like. Okay, so then I want to talk about this recursive also. If you see this recursive thing, uh, it is little I'll say complex to understand, because it is like a recursive. It means it is calling itself. Okay, and it is generally not used much, but I've seen in the real life applications where, let's say, you have a table with manager, no, reporting to manager as a single table, and you want to build a hierarchy. You can use this self-calling thing to build it. So the statement will look like that. With recursive, you mention a table name here. You create a table, and then you say as, where you will have a top uh, certain uh, table select statement, and then by union all, you are bringing the another table and clubbing together. The magic is actually here. You will see one as a level 1, it has been called. Okay, and then you are joining the table. You see this here, employees. Hmm, and here you see join employees, E on E with C as dot manager. Okay, so you see this part, E dot name to C dot manager. So it's basically self joining here, and then you're just filtering out is not null. So what it do is do a chain full recursive through the table one at a time, and then gives out the result. Okay, it's it's uh, it's a complex to understand. Let's see it in action, then it will be easy to understand what is happening. So the main idea I want to say is, whenever you see this kind of recursive, you think about it's going to do a self join with the same table and build out of it. So there is no like a second table is self-referencing to the same table. Okay, so that's what the main idea I want to understand. And applications are very limited, but I'll show you one applications which will help you to understand. So think about this. This is the real life example. So there is a person name reports to, like, VP engineering. Engineering A reports to VP engineering. Okay, then this reports to, again, same person. Okay, this guy reports to VP sales, and all these two all these VPs reports to CEO, and finally CEO obviously does not going to report anybody, so that will remain null. Okay, now if you want to know uh, this person, how this person's report, so it's a chain will be like this reports to this, and then this report to this, and if you want to create that, you use this kind of recursive statement. So let's see it in action so you'll understand. So if you click it next, the first thing, we start with the uh, level 1, which is this one. You put it select command here, so you see that name, and you put the level 1. You started with this. Okay, then you are going to do a union all. Okay, with same thing. Let's continue. You'll see this action. Now you see this level 1 up, which is 1 up going to same thing, but we are chaining right now. Okay, and then you click the next one, which is again doing 1 level up, and then you get the result. Okay, so that's the, and finally you pull the recursive table out of it, which will give you this output. So I will just give you a few seconds so that you go through these things and you see, understand this table and this table, then it will help you. Again, very specific usage, so I still don't want to spend too much, but if it come across, you know how to do it. Okay. Yeah, this one is again widely used. So I don't do want to spend a little more time here, which is called qualify. Okay. So qualify is basically window level filtering. I'll say additional at which does at the row level. Uh, if so on the top, what you see, we actually already talked about this row number partition over, right? The same thing is there, but if you whatever the outcome comes out and you want to do a second level of filtering, which is like this, you created one inner table with certain thing, and then you want to filter it out, you use this row number equal to 1 and you get that information. So same thing, instead of doing all this kind of thing which looks little complex to read, Snowflake, I think BigQuery, Databricks, all of them has created a function for SQL which is called qualify. So what it do, once the row level information is generated, it it checks those against that if it's true or not. Here you can put any value out of whatever you have created here, and you want to do the logic, you can build it. So that's like a true and false kind of check. Qualify is like, does it match with certain criteria? Your criteria is matching, select them. Okay. So let me show you with an action which will help you to understand what is happening here. Think about this as a table. This is a table where you have a user ID repeated. It has a status with time. Okay, but you want to get at the latest time for each individual. Okay, and that's your end goal. How do you accomplish that? Uh, this is the one you want to select. This is one because the for Anna the la, the oldest time is this. For Ben, this is the oldest time or date. You take that and get the status of it. Okay, you are interested in it. So this is how simple syntax look like. So you start with the the table, which is this event table, original table. You bring that all the columns. Now what you do, the first part is inner. So inner part is you partition by user ID. So first you do Anna and Ben, separate them out. Okay. Then what you have done, you order it by sort it in a descending order. Descending order means the one which is older will go on top. Okay, because that's why you're using descending. And then you uh, put a row number to it. So it will be 1 2 3. The top, this will be on top, so it will get the higher number. And once you have that, you finally filter out the number 1, which is basically the the oldest, means sorry, the newest one. Okay, so let's see it in action. You will understand. Start with this. Okay, the first thing you do is you're going to group it. Okay, so partition. Okay, so that partition has been done, and then sort it, and uh, you will see the numbering has been done for them. And now let's see what is finally qualified does is select only which is 1, because these are not 1, this is 1 that has been selected, and it has been passed to the final table. Okay, I know it's very simple, but I just want to spend a little more time because you will most likely come across this kind of a syntax. Hmm. Then uh, this is because of LLM, you'll see uh, all the loads which comes in a JSON format, and JSON will be nested JSON. You want to flatten it out. There is a reason to flatten it out, so that for the next step, for next iteration or workflow, flatten is more easy to read and comprehend. In some cases, it's all case to case basis, but you will come across kind of this kind of a syntax like raw event followed by colon double colon access. So what it's actually doing, and same you will say that you'll come across this kind of thing, later flatten. So it's nothing but it is doing flattening the JSON into uh, more raw file. I'll show you. You'll clearly understand. This is very simple. So here you'll see the same command is there. This is how the pay JSON file look like. You have a SQ with values against another value. Okay, here it has only one value, but it has uh, for ANA it has two value. Okay, A1 and A2 for SQ. For ANA, if you are expanding, you have to definitely duplicate for ANA user ID. So that is expected. So same thing is achieved using this simple SQL command. So I'll show you. So it first takes that payload uh, first for ANA, and then it will going to split those things uh, for pen again. Then you see this A1 and A2 has been repeated here, and B1. So that's what when you see kind of an explode flatten command, it's actually doing this kind of JSON conversion. Hmm. Okay, moving to the next one. This is very common uh, in most of the business. Is like you want to group by. You want to your raw data will be huge, and you want to group by region, products. So group by and then roll up. So I'll show you what is exactly. And this is also similar concept. You will see make pivot. If you have used Excel, you may have created a lot of pivots. So in SQL also you can do it. There is a pivot command available. Hmm. So very, let me show you. This is how the syntax look like, but let me show you. So you have a sales table. Okay, you start with the sales table. This is the sales table look like. You have a region, you have a product, and there is an amount for that. Okay, so here RS, you can think about sales is a revenue. So R is the short form is written revenue. Okay, now for each uh, region, you want to group them and see it. So let me show you here. Here what you're doing is group by roll up. Okay, and I'll show you what exactly mean. Now you see here what is happening. The first thing is you are bringing exactly the whole table, but the next thing is up, group by group by roll up. Okay, so each region, like say east, if I do it together for all product, hmm, so that will be like 150 here. If I do it for west, it will be again 150 here. So that is basically you are making product all, region you are still keeping separately. That's the first thing. And one more roll up, if you do one more roll up, which is like everything if you combine, what will be total. So that's called all. So it's coming. So I'll show you. So this is how first you do that each level, and then next level is all. So you start with the very grain. Uh, the grain will be decided here, and then you build up the whole table. So that's the interesting part of roll up. Okay. Now I hope this is clear. Next, we'll go to the pivot section. Pivot is you have a raw data, and then you want to just group it. Pivot help us to. So this is like a conversion. You see, a product is repeated for each quarter. So what you're doing is you splitting the quarters into horizontally, and you're keeping the product, and then you're bringing the amount. So this is how it will look like. So first thing it will do this, and then it will transform this. So this is how pivot does. Okay, very simple. You have seen most of may have seen in Excel, but you can do it in SQL by using the pivot command. So only thing you have to remember the way it has to be written. Start with pivot. Okay, open the bracket. You put which attribute you want to sum it up, which will come here. Okay, it's called a data portion for quarter. So which column you are talking about, that will go here, and then you can put each variables like q1 q2, which is here. You can pass the list also and say sp. So this will be put it here, and the rest will be summed together. So here this is automatically done. Okay, so now if this table is given to you, you want to do a reverse, just you can do that reverse also. There's a quick command called unpivot. Very interesting. I like this one because sometimes you have to transform the tables. Tables will come in this format, and you want to do some SQL join and other things, and process it. Converting this way, it helps. So unpivot is all very useful also. So again, you have this table, you reverse it. So again, the amount quarter you will need, and you do the reverse thing. Same thing. I'll just show you this. You'd start with that. You first take one, and then expand it next one. Okay, so you expanded the thing. So you see A you have taken, you just transpose them. B you have taken, transpose them. Okay. Okay. Then you will come across the most of the people use the word upserts, because basically update, you do an update and insert together in one single command. Okay, this is widely used. So if you come across this kind of thing, you will see these things. When match, then update. When not match, then insert. So idea is, in one single command, you ensure you don't duplicate things. If it is already there, certain ID, you put it, you update the informations for that particular ID. If ID is, and the whole thing is not there, you just add a additional row to the database. So it is very simply written. You start with which table you want to insert into. Okay, what is the criteria you will ensure the data is matching in the staging table, which is like the table which is bringing the new data, and this is like a table where it is going to add. So the criteria it has to match. If matched, then it will do certain replacement with this whatever emails. For example, the table T, which is the old table, will be replaced by the new table. And if it is not matched, what it will do an insert to that column ID and email, and the new value will be from the staging table. Okay, so we'll see this in action. And also want to say that for Snowflake, they have created certain inline, um, calling of AI, like agents, which will do that LLM calling, uh, and do the output inside the SQL statement, which is interesting to know. So Snowflake Cortex, I want to show you. So if you see this kind of things, so nothing to, I know, it's actually calling LLM in the SQL inside. Okay, interesting idea. So let me first show you this part. So what exactly merge, upsert, update, or insert to it? Okay. So you start with you start with the this table which need to be updated. This is the new table incoming table. Okay. So incoming table, first we'll see, okay, this is ID1, this is ID1, same ID. That means I have to replace this. Okay. This 3ID does not exist here. Okay, that means I have to add a new row, which is like a new row. So this, logically we understand this, but this command do the same thing. So we'll see it in action. So first thing, ID matched. Okay, uh, this ID and ID, both IDs has been matched. So if a ID is matched, what you're going to do? The operation is update. So this got replaced with the new email address. Okay, now next thing, this one does not have, 3 does not exist in the table, so it got inserted. B dot, or see, this row number 2 does not there in the source staging, it will remain untouched. Not going to change it. That's the whole idea. Very nice one go command to do this, very widely used in all the data pipelines. So remember this, merge into, followed by using like a staging table. When matched, you have to do this, and this. Okay, often called upsert, update, or insert. Okay, so this is all we have just covered. I'll just give you a quick reference. We have covered all these things and all these things in SQL. Quick reference. Okay, now if you uh, if you have worked in major companies, you will definitely come across Excel lookup. Okay, very widely used function nowadays. A lot of people use. So Excel lookup is also very widely used, and there is a equivalent Python code and SQL codes are available, which will do the similar operation. I will not say exact operation because Excel is cell to cell function, versus Python and SQL mostly columnar. Yeah, we can do a cell level also, but I'm talking in general. So first, let me talk about what is XLOOKUP look like. XLOOKUP function in Excel will have these kind of intermediate parameters to be updated. So you start with something called lookup value, lookup array, then return array, if not found, match mode, and search mode. This is wherever you see these are optionals, and these are necessary columns. So what XLOOKUP does, let me explain you with a real example. I know this is like a technical thing. Let's show you. Let me show you. So let's say you have a table here. This is a table. Okay, this is a table, and you want to look up certain value. Let's say you want to look up customer ID 102. Okay, so this is the customer ID you want to look up, and you want to bring certain thing out of it. Okay, so what you do in XLOOKUP, you first specify the what value you are looking for. So so here it's like, okay, 102 is the customer ID you are looking for. You will provide here. Hmm. So where, in which column you want to this this ID is available. So that you have to specify. You cannot just say go and search. So you specifically tell, okay, you have to look into the customer ID column, which is this column. Okay, which is here it is showing A. For example, you think about in Excel, it is placed in this customer ID column is been placed in the first column. Okay, so you look for that, and then you want to return certain things. Say you want to return the amount, which is column, or you want to return the name of the poster. So which is here. Okay, so what you do, you provide that column B, and if not found, it will be, you can put anything unknown or something. Okay, so that is the XLOOKUP works. So here I think it's a better example here, this table, if you see it, and then you can understand. So let me run this so you will understand. You picked for the value 102. Okay, then in the lookup table, basically this is the table, you search for that, you found 102. Okay, you are looking for 102, you search in this column, which is this column, A column. Okay, and then what you're looking for, you're looking for the name of the person, which is B column. Okay, so this B when is been derived and given in XLOOKUP. I am spending little time on XLOOKUP because if you understand what is exactly the use of XLOOKUP, very widely used, uh, that way you will able to do the similar Python and SQL which AI agent uses to derive the output. Okay, so same thing we can do through Python. Okay, and here there is something like Panda for functions import is available, and the important thing you have to see is this word, the merge. Okay, so what you are doing, you use the same logic, but you're doing at the table level operation, not like a single cell value search. You do the full table to table join, and bring that information. It will get the same thing, but it will do the full operation. So that's what I want to show you here. So what you are doing here, you have a table, let's say this order table on the top, and the bottom you have a customer table. Okay, the common thing between these two is customer ID. Okay, this is here, this is here. Okay, now if you want to know, uh, if you want to bring this in this table, this is the first table, this is, I call it left table. Okay, you see the order here, which is on the left side. Okay, so order is going to merge or bring the data from the customer, and the order table will remain left and the customer table will remain right, but you're going to join it using customer ID. So this will join with this. So for 102, expected answer will be Ben, right? So what it do, the same similar to XLOOKUP, it will do the full join, but not only like just one thing, it will do for everything. So let's see in action, you will understand this. So customer ID is been selected. from there, then you have this. This is actually your data frame creation, but let's continue. So now what is going to happen is they're going to join the ID to ID and bring that information. So this ID to ID is being joined and it brings the information. So for 101, 101, you bring here, and so 102 name Ben and region, everything is been brought it here. Okay. Similar thing, what you do the next lookup, you got the same answer for customer 102, the name is this Ben. But the only difference you see, notice the whole table is been done. So that's what I was saying. There is a slight difference between XLOOKUP and, but you can achieve the same thing. Now, if you want, you can add a further syntax command like give me where ID is equal to 102 and the name is equal to column name is equal to Ben. So you became exactly bring this level of information. So that additional information you have to do. But I want to say this can be achieved through this merge command and left join. Okay. Now same thing, if you want to do it in SQL, this is how you can do it. You just keep this table, the left table, which is order, and the right table is your customer. Join them with the ID. Okay. So on is basically gives you the equality, and this is the same thing what you did in using merge. Merge you are doing using left join and this thing. So let's see it in action. Very simple. I don't want to spend too much time. So here same IDs will be selected. IDs are joined together. You bring the left table only. So if you bring it here, you bring the whole result back to this. So you get the order ID, you see the top portion of it, and then you bring the name and region on the top right side. Again, you got the same answer. Okay, and same result here. Okay, so here only thing you did not put the customer ID. If I put the customer ID column here, you can actually see the Ben and customer ID 102. The result will be the same. One caveat here is like if there is nothing is found on the right table, which is customer table, the left table will continue to exist, and but it will instead of making it will show null over there. Okay, that's the part I'm just mentioning here. Okay, now XLOOKUP, you can do certain thing, but there is limitation of XLOOKUP. That's why I want to cover some other widely used functions in Excel, which is like filter, enlarge. So uh, real real life case. Let's say in the data you have a duplicates. Okay, XLOOKUP actually what it does, it do select from the top in the so the customer ID we are talking about, right? 102, 102. If it is uh, if you're looking up in the table where it 102 is repeated, let's say you are doing a reverse lookup. Order ID can have a multiple customer ID. Then XLOOKUP will not give you the full picture. It will give you the first instance of it. And let's say there is a question to find a certain first instance or second instance or third instance, then your XLOOKUP is limited. That's where there is a combination of function called large and filter will come uh, to achieve the same thing. Okay, let me show you an example to explain this. I know this is again going to be complex. So let's say you have a data like this, where you have a customer ID and you have an amount. Okay, and you see here, you will see there are customer ID is repeated, 102 here, 102 here, 102 here. And let's say you want to know for that customer, one particular customer 102, what is the third largest amount. Okay, so from here you can actually see, okay, this is 500, this is 300, this is 200. Okay, for 102, this is 150. Okay, this is 80. So more that, so one, two, third, this is the most likely answer should be third. You want to derive this, you want to extract this. Okay, so in Excel you can do using first apply the filter, and then using the large function you can get it. So exactly this is what I want to show it, um, what actually happening here. You are using two function is been used. So first, the inner function, which is filter, what it will do, it will look for the column B. So filter, what is doing, you have to filter this uh, this column B based on column A to be filtered for A2. So I'm just going a little slow. So what you're going to do in this column, look for the value which is 102. Just look for this column 102, 102. There is 101. Don't take that. Just take the 102 and bring this amount value. That's the filter one. Filter does the inner thing. That's first thing is it has done. Now your question is to find the third largest. So provide you once you have this, the large is another function which will select, it will sort the number from the amount, and it will look for the number 3. Okay, third largest, which is this, and it will pull it. So that's how this Excel function will work. So we'll see it in action. So we'll select first. So you see the filter has been applied. Remove that one, and then it will do the ranking of that, and finally it will select the third rank, which is 200. Okay, so this is how the Excel will do it. If you see this kind of a thing, and same thing you can achieve using Python also. So in Python, uh, what we do is something called using Panda. You can actually remove first create a subset of the data. So here on the top, it's nothing but a data frame created this table. Now to create a subset, so this is the sales table, the original table. What you're looking here is looking for the column customer ID, which is equal to customer ID provided here. So here you can see customer ID is equal to 102. This is how you can write in Python. You can provide multiple, values in one row. It's in sequentially it will pick up. So first is this. So it will take this as a 102. The second is n is equal to 3. This will, if you have third also, you can put it here with comma separation and forward. It's a way of writing in Python. Okay. So here what is happening? Customer ID and 102 is put here. So it will look for, okay, column customer ID in the sales table just equals to whatever equals to that became your subset of the table. So once you did a filter, similarly what you do in Excel, you are doing the filter here. Now once you did the filter, what you need to do sorting, because you want to have uh, third third rank, right? So you filter it out and then you do sort. The sort function is available in pandas, which you apply to the column which you have created, uh, amount. You sort it ascending, equal to false, because you want to do it in the reverse order. You sort that and then you pick up the value n minus 1. Now in Python, the numbers, it generally starts with 0, so that's why you have to uh, minus 1 here. Okay, this is a trickier part which you have to understand. For Python, indexing is done with a 0. Otherwise, you will be actually coming up with the uh, fourth one instead of third one. So let's see it in action. So you select that, you remove that first thing, then you have this one, and then you get the final third result by selecting that. Okay. Now same thing, we have learned the use of qualify, right? So that's qualify, and with along with the end function, you can actually do that uh, very easily. So this is first, it will do first you will see on the top, what we are doing is first we are filtering out the customer ID and then uh, just applying the rank on it. So let's see it. Just don't want to spend time because you already know it. The same thing, you use that, you get the ranking, and then you qualify for the 102. Okay, same idea, you can use this to build it. Now one more thing is about uh, you are seeing here like a ranking, but there is something called dense rank also. uh, there is one concept you should know in SQL. So what will happen, let's say you are ranking something and the amount is same, like $200 is same. Okay, so if you use the SQL rank function, it will not be it will duplicate number, and then it's a little challenging to understand what is happening versus dense rank. Okay, so first time let me show it how that thing you can do dense rank using Excel. Okay, so we can do it using the combination of index, sort, and unique filter and this thing. So again, what is index, what is unique, those are the new thing. I'll just quickly, index is nothing but, I'll show you, it's like a, you have a table, you can go left and right side by counting the position of it and bring the information of it. So index takes two here I'll show you. Index takes a column and row as a reference and bring the information from it. So okay, let me, instead of confusing you, let me show you in action, that way you understand. So like I said, if there is an amount which is 200 and 200, you want to separate it out uh, and make it one, because this is 200, third rank, fourth rank. Is it two different ranking, but you can make this 200 as only one rank by collapsing those things. So let me show you in action. So here you will see this will make them unique, and that way you get a dense rank like a feature. So this is how you can use it. Okay, let me show it in Python. Python already have a function called dense, which you can use it for rank, and that way it does not do things. So yeah, this is very good example where you will understand what is happening, what I was actually talking about in the top. So when you use a normal rank, so if you have sorted this amount and there is a duplicate like 200 and 200, you see it's the same amount. So you want to rank it 1, 2, 3, 3, and then the other rank, which is uh, this is the 150, it will actually skip the number 4 and it will give you the rank 5, which is what the problem is. Okay, so you want to avoid, you want to actually, this is actually technically a fourth rank, fourth position, so that you want to bring it, in this case you use the dense ranks. Okay, clear, right? Rank versus dense rank, this table actually explain, and let me show you this in action. So you start with this, you, the plain rank will be empty, and this is how the dense rank will look like. Okay, SQL also have a command called dense rank. uh, Again, it solves the same problem. It will not skip the counting from whenever there is a duplicate comes. It will it will repeat that ranking, and it will use it. So just be aware of it. There is available things like that. So same thing, action, show you. Okay, all right. Okay, so the closing thought here. If you use and understand, majorly use Python syntax or SQL syntax, which we covered here. Most of the thing, like I will say, remember that 80-20 rules. 20% of your this SQL and Python syntax cover 80% of your work. Okay, there will be certain edge cases will be there, which for which you can obviously use your own research too. But idea of is, if you go through these things, your time to understand those syntax will be much less compared to if you have to really understand what is happening. So it is recommended to understand those Python syntax and SQL syntax. If you are a part of a like a governance team, or a committee where you are going to approve the agentic workflow, it is, I will recommend that we actually go one level down and just go through the syntax and the logs, which is agentic AI workflow has created. We validate those things and make sure those things are in line with the business logic or the recommended logic, uh, and then we can confidently attest that, and that will actually, once you approve, you do an attestation, that workflow have a higher trust versus directly coming from any workflows results coming from agentic AI, and you have a one human loop layer. It increases trust, and that's the whole idea of this video. Hope you like it. Thank you very much for your time, and again, the family are happy now because the work done by agent is also been validated, so they can feel more confident that the system will work. Okay, thank you so much for your time. Again, this is just a few bullet points. This is where I want to end it. Thank you so much for your time. Bye bye.